Hi there guys, welcome to this second video on polynomial long division, and this one looks pretty much the same as the others, but what you're going to experience along the way here is the double negatives, and that's the sort of area that you're going to go wrong, if any. So we're going to start off exactly the same way. What do we multiply x minus 2 by to raise it to this power? Well, that's got to be x squared. I'm going to put x squared up there. And what do I get if I multiply x squared by x minus 2? Well, I get x cubed minus 2x squared. Now here's our first double negative that we're going to experience. So we've got x cubed subtract x cubed, that's fine, nothing. But we've got 3x squared minus 2x squared. So we're finding the remainder, we're taking these two terms away from these two terms up here. So that is going to be 5x squared. So the classic mistake is that you'll just combine those and put 1x squared there. We haven't finished, so we'll bring this down and repeat. So what do we multiply x minus 2 by to raise it to 5x squared? Well, that's definitely got to be a 5x. And what do we get when we multiply x minus 2 by 5x? Minus 10x. Now, this top two terms minus these bottom two terms. So minus 6x minus going to give us 4x, and we'll bring the minus 8 down. What do we multiply this by to get to this? Well, that's going to be a positive 4 at 4x minus 8, and because we've got that 0 remainder, happy days. If we didn't get a 0 remainder, it means that that is not a factor and we've probably gone wrong, especially if part B says hence fully factorise, which we can do for this one. So we've got x minus 2, lots of x squared plus 5x plus 4, and we can be asked to fully factorise using your knowledge of factorising quadratics. Okay. Other questions we could ask you to do is solve this, and then from there you would just solve it. Okay, let's look at the last example. Okay, so I've given you a function of f. It's a quartic function, but you'll notice, I'll just cover that bit up a second. You'll notice this looks a little bit different to the others. And the trick is to notice the power order. We haven't got descending power. Well, we have, it goes 4, 2, then 0. But we can't miss any powers, because when we start this long division process, it's going to go horribly wrong. So if you spot this, you just must always add in 0x cubed, because they're missing, and 0x terms, because they're also missing. Yeah, that's the most important thing to look out for. And then it is exactly the same. So what do we multiply 2x plus 1 by to raise it to this? It's got to be 2x to the 3. And multiply those out, and we get 2x cubed. So the top two terms take away the bottom two. So 0 minus 2 is minus 2x cubed. Bring that one down. What do we multiply 2x plus 1 by to raise it to this? Just minus x squared. And we get minus 2x cubed minus an x squared. Now again, the double negatives. Minus 17 minus 1 is minus 16 x squared. Bring down those 0 x's and repeat. 2x times what? That's going to be minus 8x. What is 2x plus 1 multiplied by minus 8x? Minus 16x squared minus 8x. So just have a little think. What's this going to be? 0 minus 8, 8x. Bring this down, and we're going to multiply by 4. And again, we've got that 0 there. So sometimes, I'm not going to do any of these examples, but they might say find the remainder, divide this function by this and find the remainder, which means you're most likely not to get a 0. But the fact that we have a 0, it means that this is a factor. Now, you'll probably find that they'll ask you just to leave it in this form, because that doesn't look like it's going to factorise. You need to do some further testing. Okay, so if they probably won't ask you to fully factorise this until you go to a higher level. Okay, hope that makes sense. Get practicing, and I'm sure that you'll soon love them.